Hi everyone, welcome back to yet another Euphoria Academia YouTube video where we do past papers. Today we're going to be doing the grade 12 mathematics paper 1 November 2023 paper, and we will be doing question 2 as well as question 3 that has to relate to series and sequences. My name is Ole and I'll be taking you through it. Question 2 and 3 is a total of 26 marks, and it runs from question 2.1 all the way up until question 3.2. So without further waste of time, let us get into it. Right, for question 2.1.1, we're asked to find the value of the 91st term. Right, now we're told that we're given an arithmetic series, so I'll just go ahead and write down the formula or the general form of an arithmetic series, and that is Tn is equal to a plus n minus 1 multiplied to the common difference of d. Now in this arithmetic series, I can see that we have 7, and then the next number is 12, and then the next one is 17. So I can already see that our common difference is 5, and then the first term is 7. So all we have to do is just put that in our formula. Tn is equal to 7 plus n minus 1, and then the common difference of 5. Now we're asked to find the value of the 91st term. So T91 is equal to, let's just substitute what our n will be, and our n will be 91, and we just need to subtract 1 from it. And when you put all of that in your calculator, you will find that the 91st term is 457. For question 2.1.2, we're asked to find the sum of the first 91 terms. Alright, so we already know that we have an arithmetic series. So what's the general formula of the sum? Right, so Sn is equal to n over 2, and the bracket we have 2a plus n minus 1 multiplied to a common difference of d. Now all we have to do, we already have these numbers, we already have what we need to substitute. We worked out what our a was, we worked out what our d was, so let's just go ahead and substitute there. So the sum of the first 91, and then our n is 91 divided by 2. Our a is 7, our n is still 91 minus 1 with a common difference of 5. And once you put all of that in your calculator, you will find that it is equal to 21,112. So for question 2.1.3, we're asked to calculate what term number is equal to 517. Now we already have our general formula. We got that in the first question, and our general formula was Tn is equal to 7 plus n minus 1, so common difference d of 5. Now this essentially means that our answer is 517, but we don't know what term number it is. So let's just substitute what we know that all of that is equal to 517, 7 plus, we do not know our n, minus 1. And let's just do some algebra. So we're going to take the 7 to the left hand side, so we're going to subtract by 7. We're going to be left with 510. and that is equal to n minus 1 multiplied to 5, divide the 510 by 5, and then add a 1. We're going to find that our n, our term number that is equal to 517, is 103. Term number 103. For question 2.2.1, this is a new question, by the way, and we are told that we have a quadratic number pattern. Now, a quadratic number pattern, we know that it is in the form of Tn is equal to an squared plus bn plus c. Alright, and for 2.2.1, we're asked to show that T5, so the fifth term in the sequence, is equal to 111, after being told that T1 is equal to 3, and the first difference between the two terms, the first two terms that is equal to 9, and the first difference between the third and second terms is equal to 21. Alright, so let us put that into a diagram that will make sense to us. So we're trying to find our fifth term. Alright, so all the way up until T5. We are told that our first term is 3, and the first difference between our first two terms, we're told, is 9. So what is term number 2 from there? 3 plus 9 gives us 12. Alright, what else are we told? We're told that the first difference, between our third and second term is 21. So 12 plus 21 is going to give us 33. Alright, I think from here we can even figure out the second difference. Our second difference is 12. So that means our common second difference should be 12 amongst all of these. Alright, so let us work our way back. 21 plus 12, that is also going to give us 33. So 33 plus 33 is going to give us 66. That is our fourth term, and our common difference, or our common second difference, is still 12. So we can work our way from there. 33 plus 12, that is going to give us 45. Now 64 plus 45, that is going to give us 111. So therefore our fifth term is 111. For question 2.2.2, we're asked to show that the general term of the quadratic pattern is equal to 6n squared minus 9n plus 6. Now this diagram, I just copied it from what we have from the top, and we just need to figure things out. So we already know that the general form of a quadratic pattern is Tn is equal to an squared plus bn plus c. Alright, so we already know that our 2a is equal to our second common difference. So in this case, 2a is equal to 12, which means that a is equal to 6. Now if we go up, we know that this guy over here is equal to 3a plus b. So 3a plus b is equal to 9. Let us substitute what we have for a, which is 6, oops, that should not be there. That is equal to 9, and therefore our B is equal to -9. Now we also know that term number 1 is equal to A plus B plus C. That should give us 3. So when we substitute what we have A as 6, we have B as -9, and we don't have C. That is equal to 3, all of it. So 6 minus 9, that is -3. We have to take it to the right hand side, so we're going to add a 3. So therefore our C is equal to 6. And finally, after getting all our variables, we know that Tn is equal to our A is 6n squared plus our B is -9. So I shouldn't have put that 9 over there. 9n, and then our C is 6, so that is plus 6. I'll just write it in the way in a proper way, and that is what we have, and that matches with what we're meant to show. All right, for 2.2.3, we're asked to show that the pattern is increasing. Now, every single time you hear that something is increasing, it should be in like a form like that, or it's just a straight line going up. And whenever we see anything like this, especially when it comes to paper 1, you should be thinking inequalities. All right, and to solve this inequality, we're going to use the quadratic formula. Now, you can see that our discriminant, so what is underneath the square root in b squared minus 4ac, if we were to substitute what we have, our b is -9 squared minus our a is 6, and our c is also 6. Now, if you put that in your calculator without doing the square root, you can see that the discriminant will give us our b squared minus 4ac. That result will always be less than 0. So it's not ideal for us to use that. But if we use the beginning bit of the quadratic equation, we get something useful, because we're only meant to show that this thing is increasing, right? So the beginning bit is just the minus b over 2a. Okay, so let us just replace or substitute what our b is. So that is going to, our b is -9, and that is divided by 2a. Our a is 6, and the answer that we're going to end up with is going to be 3/4. So our n is equal to 3/4, but in the question we're told to show that it's increasing for all natural numbers. So natural numbers do not include 0, and these are our counting numbers, so n cannot be 3/4. So the minimum value of n has to be 1. It has to be 1 because that's where we're going to begin. We can't say 3/4, but the next natural number is 1. And for all for n being all natural numbers of n, because we already know that n it starts from 1. Right? So if we look at our minimum value, our lowest value of 1, we can see that our formula, or our general form of this thing, 6n squared minus 9n plus 6, if we keep on substituting our natural number starting from 1, we're going to see that this thing is always going to be positive, right? And it is always going to be increasing in that positive regime. And you can see that for yourself if you were to put the values of, let's just say y is your result and your n is what you substitute. So you get, if you substitute 1, you're going to get 3. If you substitute 2, you're going to get 12, and so on and so on and so on. So it's increasing. All right, for question 3.1, we're given a new sequence. We're given a geometric series, meaning that we have to find our constant ratio r and our first term a in order to get through the question. All right, so for question 3.1.1, we're asked to write the general term, or the general term of the series. Now we have 3 plus 6 plus 12. I think you can see that all that we're doing, because it's a geometric series, we're multiplying from 3 to 6 by 2, 6 to 12 by 2. So our constant ratio r is equal to 2. Our first term is 3. So the general term, or the general form of Tn is equal to 3. Our first term, r will be 2 to the power of n minus 1. For question 3.1.2, we're asked to calculate the value of k such that the summation of what we have there next to it is equal to 98,301. So I think first things first, I would start by trying to understand exactly what this means. So let me just rewrite the question and P. All right, and then I'll write what the equals is. All right, so essentially this sigma, what is it? What is it? So our starting index is 1 and our ending index is k. All right, and once we add all our values up until the index of k, we're going to end up with 98,301. Let us see if we can add the first 3. Let's just see what we end up with. So that will be equal to, if p starts at 1, our first term then is going to be, I'll just write what we have on the bottom here. So our first term will have p will be equal to 1. So that will be 1, and that is equal to, if you put that into your calculator, that is going to be equal to 3. And then for the second one, our p is equal to 2, and we're going to find that that is equal to 6. And then for the third one, we have our p being equal to 3, and that is going to equal 12. Well, I can see that these 3 terms are exactly what we have in the geometric series in the first question. So if we're asked to sum up these things all the way up until k, we have the formula for summing up geometric series, right? So we're going all the way up until k. We can use that because it's essentially the same series, just written in a different way. So our SK will be equal to 98,301. All right, and SK is equal to our A multiplied to 1 minus R to the power of, in this case, it'll be K over 1 minus R. Okay, so that is equal to 98,000. Now we're just substituting 301, which is equal to, our first term is 3, and our R value, our constant ratio, is 2. That will be raised to the power of K, and then 1 minus 2. Alright, cool. Now, after doing some maths, we're going to see that ultimately we're going to end up with a result of 32,768, and that will be equal to 2 to the power of K. Now, if you want to find K, we're just going to use our log rules, and we will find that our K is going to be equal to the log of base 2 to 32,768, and if you put that into your calculator, you will find that K, and therefore K is equal to 15. So question 3.2, we're told that we're working with a geometric sequence as well as an arithmetic sequence, and they have the same first term. So I already know that our A is the same for the arithmetic or the geometric. So our A is not going to change. I'm just going to keep it at that. All right. But what needs to happen? Okay, bullet point number 1. The common ratio of the geometric sequence is 1 over 3. So we know that our R is equal to 1 over 3. Okay, and then the common difference of the arithmetic sequence is 3. So we know that our D, common difference D, is 3. Alright, the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. Now let's just try and write that in a mathematical sense. Alright, so our S22 of the arithmetic, I'm just going to write array, is equal to 734 more than the sum to infinity of the geometric sequence. So it's equal to the sum to infinity of the geometric plus 734. That's essentially what all of this means. So I think we need to find specific things here. So first and foremost, we need to calculate what S22 is, and then see if we can work with the sum to infinity. So without further ado, let us start with the arithmetic side. So the general term of summing an arithmetic sequence, Sn, is equal to our n over 2, and then in the bracket we will have 2a plus our n minus 1 multiplied to a common difference of d. Alright, now let's just replace. So we know that it's the first 22 terms. So n will be 22 divided by 2. The common difference, that's not the common difference, the first term is what we're looking for, so that will stay the same, and like I said, our n is 22, so we're going to substitute that. We're told that the common difference is 3, so we're going to substitute that, and let's just simplify what we have. So our S22 is equal to, if we do some mathematics, we're going to find that we have 22a plus 693. All right, cool. So the next one is figuring out this sum to infinity. All right, so for a geometric series, if our r lies in between -1 and 1, we know that as n tends to infinity, so the number of terms that you're adding, it will essentially mean that our r to the power of n, that will tend to 0. So in the general formula of adding a geometric series, we have a situation where we have Sn is equal to a multiplied to 1 minus r to the power of n, and that is divided by 1 minus r. Okay, so if this will be 0, if this tends to be 0, that means the sum to infinity is going to be the following: a over 1 minus r. Okay, so let us substitute, and because our r is actually 1 over 3, so we can confidently say that that's our formula, a over 1 minus r. Our first term, so our sum to infinity is equal to our first term a, which is what we're trying to find, over 1 minus our r value is 1 over 3, and if you do some mathematics, you're going to find that we have a result of 3 over 2a. Okay, so now we have the sum to infinity, we have the sum of the first 22 terms, so we're just going to substitute what we have and see what we end up with. So continuing from what we have from above, we have to substitute S22 is equal to sum to infinity plus 734. Alrighty, so what we're going to do is substitute what we have. So we have that our S22 is equal to 22a plus 693, and that is equal to 3a over 2 plus 734. Now, if we take our a's, or this 3a over 2 to the left hand side, we're going to find that we will get a result of 41a over 2, and that will be equal to, if we take the 693, so we subtract this 693 from 734, we're going to find that we have 41. Therefore, our a, which is our first term, is going to be equal to 2.